Well, I did make one last attempt at trying to salvage this. I thought maybe that if I completely exposed one of the coils and maybe even the other coil next to it, maybe I could bypass the broken windings and splice in to that somehow. The problem is, as I unwrapped this and I took off broken pieces of wire and cleaned out the epoxy from between, I can clearly see 3 conductors going from this winding and going into this one, and 3 coming out. So they got an unusual, well, probably not unusual for what it is, but they've just got it wound in a way I didn't expect. If I had to theorize, I would say that what's going on here is that there are actually 3 coils in parallel. So what they're doing is they're taking 3 conductors and winding them around the post before they come to the next post, and winding this. So they're winding 3 conductors in like a triple pack from one to the next. That creates a big problem if I want to try and bypass, because this is all wound around itself. So best case scenario is, even if I thought that that's how it was, if I was sure that's how it was, would be to expose 3 conductors here, splice 3 new wires on, wind them onto this post. But I don't even think that's, I'm just guessing at how that is. That might not even be right, because I see some other little conductor ends down here. I can't tell whether or not that's more wires that I just broke just now, trying to get this epoxy out of here, or not. It's kind of hard to tell over here where these wires go. But there's one here. There's one here. This one appears to come out from over there and goes to this coil. It might be even more than 3. Looking over at this one, which I didn't really expose too much, I just see what looks like just 3 wires coming out. So I'm thinking these 3 wires right here, maybe all 3 of these wires terminate together and went to one of the connections, the transition to the stranded wire, because this is the area right in here where that connection happened. But that doesn't explain why I have more than 3 wires coming out of this coil heading towards this one. So that's where I just think my limitations are gonna come into play here. I'm tempted to just unwrap all of this wire completely off of this to see. I seem to have 3 conductors running around this right now. I unwrapped any ones that just fell off, because that would be where it was wrapped around and then broke. But this really long one here was wrapped around here. But this one, once I unwrapped it, it looks like it's actually appears to be going to this coil. And you see how short it is. So this must have been wrapped around several times and then reconnected to one of these. There's also, these are all shellacked or whatever. And that doesn't make it easy to take this off. And then, as if that wasn't bad enough, the epoxy is still in some places where I can't get to it. And then it stops dead because what apparently happens is it goes underneath one of the other windings. This one just stopped unwinding, and it looks like it goes underneath, down underneath here, so that's interesting. Looks like the 2 of these 2 right here don't unwind anymore, and they now go underneath this winding. And this one is some epoxy in there I just can't get out. Alright guys, I decided not to give up, and I believe I'm making some headway with this thing. So, other than some really small little pieces here and there of wire, alright, a couple little pieces here. Here's two sizable pieces right here. These are all going to be wasted. And these really long ones here, I'm going to rewind these onto here. But what I was able to determine and isolate is that there are 3 windings. So no wonder why the resistance when measured at the 2 output wires is so low, because I measured each winding separately. Each winding measures 1 ohm, and these windings are in parallel. So if you take 3 1 ohm resistors and put them in parallel, the equivalent resistance of that circuit is actually lower than the equivalent resistance of that circuit will be lower than the lowest of any of the parallel resistances. And in this case, they're all 1 ohm. The actual resistance formula for this, believe it or not, is 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3, which, because R1, R2, and R3 are 1, that reduces to 1 over RT equals 1 over 1, which is 1, plus 1, plus 1, which is 3 ohms. I'm sorry, which is 3. Which, take that formula, it becomes 1 over RT equals 3, which if we invert both sides of that equation, RT, which is the total resistance, is 1 over 3, or 1/3, which is roughly 0.33 ohms. So that's why that measured so low. That also might be why I wasn't able to get the inductors to ring really well with my inductance tester, because I had 3 inductors in parallel. So what I'm going to do is I've already done resistance checks. I was able to isolate 3 wires over here. And they're very short, but 3 wires right here. And then on this center one right here, I have a total of 6 wires. I've got 3 right here, 4, 5, and 6. Okay? So you got 3 in and 3 out on this centerpiece. So right now this centerpiece is completely isolated from the rest. So what I gotta do is I gotta tie in this back to this. No, actually, these 3 right here are gonna be tied together to one of the output wires, and then 3 of these are gonna be tied to the other output wire, and then the other 3 of these are gonna go to this side here to complete the circuit. That may sound confusing, but it makes sense in my head. Alright, but for right now, what I'm going to do is, I think I'll try and ring... I just did a resistance check from each one of these to each one of these, and figured out that they're not shorted to each other, which is good. I've got 3 separate windings in there that are intact. Alright, so I'm hooked up to just 1 winding, and now when I ring that inductor, it's ringing like crazy, over 200. So that was why I couldn't get this to ring before, was because the 3 inductors were in parallel. So I'm going to finish testing the other, ringing the other inductors, the other windings, and just making sure they're okay. Alright, took me a while to do, and it may not look pretty, but I actually got this thing back together. Here's one of my connections here, there's another one there, and there's another one buried way down in there. That was tricky to get. So, You know, the enamel wire, you have to scrape off the enamel to be able to solder to it. And so what I did was I scraped off the very ends where I needed to make two connections, and twisted one around the other, and then flowed solder in there. So now when I do a resistance check, I know that I have one wire going into this coil, comes out of this coil, goes into this coil, then is continuous coming all the way around, and then comes out to one of these wires. So now I know I've isolated and tied together well, not tied together, but I've isolated the three separate windings as they come around. So I got 1, 2, 3, 4, 5, 6 wires total. Now I've just got to figure out how I'm going to tie those together. If I just tie these three together and then tie these three together, that will put the three windings that are wound around this thing in parallel. But I'm not positive whether or not that's correct. It could very well be that I'm only supposed to tie 2 of these together, and then 2 of these together, and then use just this one wire and this one wire to make the connections. What that would have the effect of doing is that would have the effect of tying the 3 windings in series. But it would do it in a kind of a weird way. It would kind of be like, let me back out here. It would be kind of like the current would flow in, go around this whole thing, going through all of these windings, then reverse, go back around this way and come back to here, then reverse again, then come back out to here. It'd be kind of a weird way, and I don't think it's going to be wound that way. I think it's supposed to be 3 windings in parallel. Also, each one of the individual windings that are in parallel right now, if I measure each winding, it's about 1 ohm. And if I was tied together in series, then my total resistance of this stator should have been around 3 ohms. And I do remember that when I did get a reading off of this, that I was actually getting more like less than 1 ohm, which again, I did the math for that earlier and figured out that, yeah, this should be something more like 0.33 when it's in parallel. 3 1 ohm resistances in parallel should come out to be about 0.33 ohms, which is what I was getting. So I'm going to tie them together as parallel. Well, I was having a heck of a time getting the enamel off of this wire because it's kind of tight working quarters in here, and I was using this cheesy scalpel and just kind of scraping it off, but I wasn't getting it really clean, which was giving me difficulty when I was splicing these together. And what I figured out is that if I use a really small stone on my Dremel tool, it really does a great job, and I really have really good control over. I can just get in there and get it cleaned up without. If I'm careful, I don't have to worry about hitting the adjacent windings, causing myself a whole other problem. So. Actually seems to be doing a pretty good job of cleaning off the enamel, because with the enamel on there you can't get the solder to stick and you can't really get a good electrical connection. The enamel is the insulating material that is what keeps the windings from shorting against each other. If you just took bare copper wire and wound it around, it would just end up being a lump of copper. So what I'm doing now is I'm getting ready to join these 3 wires together. Because this one's so short, what I'm going to do is I'm going to wrap the short one around that one, solder it there, and then wrap this one up a little higher, and then attach my lead wire, maybe to the 2. Now, in the original construction of this alternator, the copper wires were connected to the stranded feed wire with a crimp connector. And the problem is, even if I had a crimp connector like that, I can't really get the tool in there to crimp it. So what I'm going to do is I'm going to just use a crimp connector as a sort of as a sleeve and flow solder into it. So it's not going to be as good a connection. It's not going to be as good a mechanical connection. Electrically it'll be fine. Problem is, because of the severe vibration that's involved, that's why I think this was originally a crimp connector. Now I'm going to repot this whole thing with epoxy, so that should help. But I wouldn't be surprised if this fails again. So the question is, well, why the heck bother doing it? Well, again, because of the cost of the replacement alternator being so high, I'd rather do this, get this alternator, if I can get this alternator to work, even for a little while, long enough to maybe find out whether or not this motor is worth, keeping. Then if at some point down the road, the only thing that happens is the alternator fails, then I might seriously be willing to consider investing the money in a replacement alternator. Alright, so what I got here is I got a crimp butt connector. The plastic's longer on each side of this connector than it needs to be. So the first thing I did is I already started making one here is I cut off the excess plastic. But I can put this on here now, but the problem is as I heat this up, this plastic's going to have a tendency to melt and make kind of a mess. And I'd like to be able to actually apply heat right to the outside of this tube and flow the solder into it. So I want to get this off of here. So what I do is I put a little fiber cutting disc on my Dremel tool and see if I can't just slice this off. And these little sleeves are copper, I can see, because I just rubbed through the outer coating on there and I can see copper. So these are copper sleeves that are coated with some other material. A little hard to pry it apart. There we go. One sleeve. Now there's a little crimp already in the middle of this sleeve, and that's so that the wire can only be inserted so far from each side, because this is supposed to be a butt crimp connector, two ends of wires connected together. So I'm going to want to I'm going to leave that exposed, because that's going to help me flow the solder in there from that side. So I'm not going to worry about that. So if I put this little connector on here on the end like this, theoretically I should be able to heat this up and flow solder right into this whole thing. Okay, I have no idea why, but somebody's car alarm is going off. Alright, so I've got one done. All I have to do is insert the stranded feeder wire in the other side and solder it in, but I'm gonna finish the other one of these first. So I've got to tie this wire, and this one down here on the bottom. I've got to tie those three into a bundle. All right, I guess I could do some testing. Yeah? Yeah. Yeah. Alright, I guess I could do some testing. Really, I'm just going to check the resistance of the whole thing, and it should be 0.33 ohms. Not bad. Well, I had moved the alternator out of the frame of the camera. So, probably end up editing out all of that. Well, the camera was looking at nothing while I worked. So now I'm installing the wires to my little connectors. Pretty good connection. And then I had saved the old wires so that I have a pretty good idea of how long I want the replacement wires to be. And I can even cut them a little bit longer for now. I can cut them to length after I'm done. So now I'm going to start repotting this whole thing with epoxy, because I don't have potting material. I decided I'm going to shrink wrap these connections with heat shrink tubing, only because they're going to be in such close proximity to each other that if they move and end up touching each other before the epoxy sets up, I might have a problem. Alright, now I can work on epoxy in this thing.